Okay, so we are on practice 3, which is on page 64. So let's go through something else. So can you turn to the front of your books now? All right. And I'm going to go through, even if you're all the way halfway through some questions, I want you to write down what we're doing now for me, please. So don't just head down and carry on, please, even if you feel you can. I just want to go make sure we've got some notes, one for each question, and we can have a bit of discussion. If you're good with it, you can help us, those that are not quite there, help us out. Does that make sense? All right. So, for instance, question 1 was about converting 0.87 into a fraction first and then into a percentage. Okay? Right, so who can tell me how to turn 0.87 into a fraction? Okay? Good. Yeah, so we know the lowest one is the hundredths because it's in the hundredth. And by the way, I like the fact that you didn't just tell me the answer, you actually gave me a this is how. So that's what I want from everyone. So we've got 87 because it's in the hundredths column. All right. And then as a percentage, that makes it nice and easy, doesn't it? Because, Emma? Exactly. Again, good explanation. It's 87 because 87% means 87 for every 100. So 87 for every 100 is the fraction that we have. Do you want to make sure you've all written that down? Yep. Some people aren't. Yeah, so we've got 0.87, which is 87 in the 100ths column. All right. Well, we've got 7 in the hundredths, but the 8 is in the tenths, and we know how many hundredths make a tenth. Nope. If you move up one column, you move up 10. So there are 8 tenths, which is 80 hundredths. So that's why it's 87 hundredths. Just like if we had normal number 87 not as a decimal, why is it 87? Well, because we have 7 units and then 8 tens. But we say we have 87 units, yeah? That works that way. Now, it's not in the book, but I just wanted to clarify with you, because you've done your assessment, 0.87 recurring, is that, well, actually, what is it as a fraction first, and who can explain? G?
It's going to be, so let's say 0.87, and then we can write a lot of it, because always it's going to...
Keep it simple, just...
Oh, it's, when it's a recurring decimal,
yeah.
it's not going to be a 10 or 100.
Right, so that's a good point, because it doesn't stop in the hundredths column, does it?
It doesn't make it.
So we get 0.87, but then we've got another 8, and another 7, and another 8, and another... So we don't stop in the hundredths column. That's why it's not a 100. So, what did we figure out in our assessment, G?
So it will end in 90.
The denominator is going to be 99. Now, I know, for instance, that Des tried to go and search up a complicated way of figuring that, and you will do that in M3 to show that it's 99, but we don't need to, right, at the moment. There are ones, by the way, that you can't just put it over 99 that are recurring, but at the moment we're only dealing with these ones. So it's over 99, and then what do we do for the numerator? The recurring decimals, so it's 87. Okay. Now, is that larger or smaller than this one, Kieran?
It is smaller, no. Larger because it's... I would say smaller because that the recurring decimals, the denominator is less, but so I'm not sure.
Okay. Had a nice discussion with yourself there, but at least you're thinking about both sides. Keen, what do you think?
Well, I have two things to say. One of them, the first one is it will be the first one because it doesn't go on.
So you're saying the first one is smaller, yeah?
Yeah. And sorry, bigger.
The first one's bigger.
The first one's bigger. And the second one's smaller. And I also want to say what happens when the 99 becomes 1.
No. Tristan, what do you think?
I think, I do think the top one is bigger because it has more value. But at the same time, the bottom one could also be bigger because it goes on forever, and those tiny bits eventually amount to something.
No, yeah,
add them
exactly.
all
I
up.
think you're all answering
So-
your question and going against what you know is true. That's what
The
you do.
bottom one is bigger because the answer would be 87.87%.
Okay, that's a good way to think of it. This as a percentage would be 87.8787, blah blah blah, and we would round that to 87.9%, wouldn't we?
And then we take the
So, like you're all saying, guys, this one, the first one, stops at 87. This one has another little bit added on. So it must be bigger. Yeah? But you were all saying that and then going against your logic in your head. Alright? So the 8 must make it a little bit bigger. Yes, right?
Yeah, I would say the bottom one is 87 over 99 is more amount of something than 89.
Yes, actually, I was going to ask, did anyone figure that one out as well? If I've got 87 from 100, or 87 from 99,
This one's
Closer to 99.
this one's close to 90. Also, if I've only split it into 99 pieces, not 100, each piece must be slightly bigger, right?
Yeah.
The smaller the number on the bottom of the fraction means you cut a cake into less pieces, which means the cake pieces must be
Bigger.
slightly bigger. So a smaller number means the fraction is bigger. The numerator is how many of them you have. Yeah? So there's a good point. I'm glad we went through this. So, are you all good with decimal, fraction, percentage? Has anyone got any questions on that? No, I'm finished yet. Okay, right. So just moving on. So if I then said to you, so this will be question 2. It says write 12% as a decimal. How would you do it? Bonnie?
You put the 0.12.
I'm not going to write that just because we don't say that. How do you say it correctly? 0.
1, 2.
That's it, yeah? Sorry about my computer just glitched there. 0.1. We don't say 0.12, do we? Because 12 is a number in the units and tens bits. Yes, no. Is that- Yeah. We've been saying it because you guys have been doing this really well. You've been understanding that 0 and 12 hundredths. Yeah? Which then helps you turn it into a fraction, which is 12 hundredths. Which can be simplified, can't it?
Yes.
Yeah? But I'm not going to worry about it. But yes, we say 0.12. But yes, Bonnie, well done. If you put the 0 in there. So if I said to you 0.04, what's that as a percentage? Decimal, Simone? Sorry, is that a percentage?
400. No. As a fraction?
What? So, well, if you want to do it as a fraction first, the one is a percentage. Zavi, what do you think? As a percentage. Nope. Okay?
As a percentage, it will be 4%.
It'd be 4%, wouldn't it? Because if we think about it as the fraction, it would be 4 in the hundredths column. Alright?
Because of the math
0.004.
Good. So let's say I said 0.203 as a percentage. Karen?
203 over 1,000 for a fraction and then divide into
So we can do 203 over
20 point, so as a percentage it will be 20.3%.
20.3%. Good. Yeah? Makes sense? So if I then said convert 6.1% into a decimal, Simone,
It would be 0 plus 0.6. No.
shall I go for it? It's 6.1%. We could say 6.1 in the hundredths column, but this is we don't write fractions with decimals, so we don't ever do that, but it might help you thinking. So that would be 0.0 because the 1 is in the hundredths column, yeah? Got it? Is that what you were all going to say? Good. Okay, and then just finally, so we're kind of looking at question 5 now. We went through a lot of different things there. So question 5. Do you want me to pause to write some of this down? Yes? No? If you've not written it, you need to be writing it. That was the point. So let me pause to make sure you've written those examples. Has anyone spotted a good way, like an explanation of how you can go from the percentage to the decimal? G?
12% means 12 in a hundred.
Yeah.
But then if 0.1 is in the hundred, so that's 100.
So this is like doing 12 divided by 100. Yeah? So how can I go from a decimal to a percentage? We do 0.04 times by 100. Yeah? That might help me. So for instance, 6.1%, we could do 6.1 divided by 100 would tell me that it was 0.061. So let's say you were allowed to use your calculator. That's what you would do, okay? Okay. So question 5, just quickly. Alright, so let's just say it says, which numbers are equivalent? So I'm just going to check, how would you... Sorry, Bunda, did you have a question or did you have a...
Yeah, I
Yeah?
have a comment. Can you move the thing at the top there? Like,
Well, I rewrote it here. But, yes, I know, but that's it, I rewrote it. Yeah. Okay, so 42 from 150, we've got 16% and 0.28. And the question is, which numbers are equivalent? Actually, so we've got 21 over 60, and we've got 28% and 0.286. So they're asking you to decide which ones are equivalent. How do you answer? What process do you go through? Jordan? Yeah? Yeah? Is that, those are the two, yeah? So we know 28% and 0.28 are the same. They're equivalent. But what about the others? Is 0.286 equivalent to 28%? No. So 0.286 is not the same as 0.28. Let's not get into the habit of saying, oh, but if I round it, because it wouldn't happen, right? What about the other ones, though? That it's a bit more tricky. What could we do? Kieran? Well, how can I show? That's what I'm after. Jordan, what did you do? What did you get? Hard, isn't it? So this one, I would say, this is where we did some work. Can you divide 150 by 3? So we go to 50. Can you divide 42 by 3? Yeah, 4 plus 2 is 6. Can divide by, what's 42 divided by 3, Emma? 14, good. So then I can go up to 100, which would make it, how many out of 100? If it's 14 from 50, it's, John? 28 out of 100, isn't it? So that is 28%. So because we've done our equivalent forms, we know that 42 from 150 is the same as these two as well.
But is that, is 16 equivalent to 21? I have no idea. I just feel like
Well, let's look. What form could we put it into?
0.1.
Yeah, we could write it as 0. This is what this question is all about, is putting things into different forms to do their comparison. So 0.16, all right, or 16 over 100. Now what about 21 divided, any way of doing that? Yeah,
You divide both of them by 3.
good, so that would be,
21 divided by 7. 16 divided by 3.
yeah,
Then you have 20. And then you can multiply 20 by 5.
yeah, so if we multiply that by 5 and get to the 100 that we're looking for, multiply this one by 5 and we get 35.
Okay.
So no, that's not the same. And then we know this one is not the same. All right, so what G said was, we need 60 to 100, but it doesn't go straight away, does it? But if we divide it by 3, we can drop it down to 20. Why 20? Well, because 20 will go to 100 by multiplying by 5. So then I have to divide by 3. The first step was divide by 3. Gets me to the 7, and then 7 multiplied by the 5 gets me to the 35, it should say. My computer's going slow, it's got too many things running. 35, so I know that that one is not the same as 16% or the same as 20. So I think we've got the 3 that are equivalent, yeah? Yeah, I've got so much going on, I've got lots of things. Yes, King? Alright, so with question 5, it's about writing it in the different forms. Alright, so you can compare. No one's asking you to just look at the numbers and know. The idea is to change the forms. So that's what we did. Any questions about anything we've just done now? Alright, so you will then know. So let's just bring this up. Your book. So we're doing this practice. Your target now, alright, is to try and get through this exercise. Alright, we've just been going through it like you've just seen. If you've done the first ones, that's fine, if that's where you are. If you're getting to a stage where you have to compare, I know you'll notice it says, it doesn't say anything about calculator. Alright, now I would like you to make the decision. If you can do anything without a calculator, please do it without a calculator. If, however, you get to the stage where like I've been doing this for a minute or two and I just can't do, I know what to do and I can't do the calculator, get your calculator out. But try first But if that's what's stopping you solve the problem, get your calculator out. Does that make sense? Yes, Karen?